Welcome to the Global AI Frontier Lab. Today was the inaugural meeting of the Advisory Council for the Global AI Frontier Lab. So big day for the lab, and they included this public event at the end so that the broader community could enjoy a discussion with two absolute bigwigs of AI, Kyunghyun Cho and Will Falcon. Kyunghyun Cho is a professor at NYU. His works have been cited nearly 200,000 times, which is insane. He's one of the best known names in AI, regularly giving keynotes at the top AI conferences. You had a keynote at NERDS just in December, right? Which is one of the most prestigious AI conferences in the world. And some of his key breakthroughs are on things like neural machine translation and attention. Will is founder and CEO of Lightning AI. He was actually a PhD student for KyunHyun previously, co-supervised by both Kyunghyun Cho and Yann LeCun. And he was doing his PhD research. And my understanding of the story, they might talk about it a little bit more, is that they noticed that Will was getting his research done more rapidly than some of the other PhD students. And it turned out it was because he'd been building this framework for speeding up PyTorch model training, which he decided to call PyTorch Lightning. And that took off. It now has 400 million downloads, or nearly 400 million downloads. And so Will is, I guess, do you think he'll ever go back to that PhD?
We talk about it a lot.
We do.
After IPO first, though.
Yes, there is a strict limit of the 10 years on any PhD students at NYU. And then Will still has like a couple of years left on the 10-year limit. So we'll see.
You just
If
need to
he IPO quickly enough, maybe he'll have a chance.
Yeah, and so in the meantime, Will has been very busy as founder and CEO of Lightning AI, which is a key partner with the Global AI Frontier Lab. And Will, you sit on the advisory council as well, as many other people actually here in the audience do today. And I mean, the Lightning AI, it's unreal. I think they'll talk about it more in here as well, but thanks to a recent merger with Voltage Park, now serving over 400,000 developers and companies. It's the third largest neocloud by GPUs with over 35,000 GPUs. And the craziest stat for me is that 2 years ago, no revenue, and now $500 million in ARR, which is completely mind-blowing. And so, yeah, now you're going to hear in this fireside chat more of that history between Kyunghyun and Will, what Lightning does, what the Global AI Frontier Lab does, and the role of startups and academia in general in modern AI. So yeah, enjoy this chat for about half an hour, and then we'll do Q&A for another half hour after that.
All right, thanks, John. Well, welcome everyone. I'll try to make it as entertaining as possible, and then I think that Will try to add his best as well. One day, William actually came to my office and then told me not about research, but started to rant about the status of the software or the software development paradigm that we were using to train these deep neural networks, and then doing research using those deep neural networks. And then he started to tell me about this lightning that he was creating. I was like, great job. Please go ahead. And the reason is that every single computer science PhD student, of course, codes a lot, implements various software frameworks here and there, but almost none of them actually gets picked up on by the others, and then becomes anything beyond their, let's say, PhD dissertation. But somehow, a few weeks later, if not a few months later, William started to come back increasingly more to me, and then telling me about not the research, but about this Lightning platform. And then one day, he told me that he decided to make a startup and then go at it. And I had to ask him back then, and I have to ask you now again, is that what made you think that your software was any better than any other computer science PhD student software? I've seen like millions of them. They're more or less all the same. But somehow you decided that yours was special. What made you think they were special?
I don't think I decided. I think the market decided it was special. I don't think it was special. I put it out there because it was useful. And other people found it useful, and guess a lot of people decided it was useful too.
That's an interesting question. But the useful open source software doesn't necessarily translate to a business. because open source software, almost by definition, is something that you can go there, download, and then start using it overnight. And then Lightning was the same way. So everyone was using it. I'm still using it. Thank you. It's a great piece of the software. But how did you know that there is a business opportunity? Because that's often something that PhD students are not trained to spot. Did you see something? What was the spark that you saw there?
So before I started my PhD, I sold the company. So I knew something about making a business, I guess. It wasn't the best business, but it was fine. I think what was different here was that enterprises specifically were like asking for this and pulling me in. And a lot of people talk about product market fit as this like elusive thing. It's kind of like if you've never had it, you don't actually, I can't really describe it to you. You just don't know, right? But product market fit isn't like, oh, we'll have one user and they love it. No, it's like the market's like pulling you and like dragging you, and it feels very like taxing. You're probably working 24/7, and you're getting a lot of demand for this thing that you didn't ask for. That's product market fit, and so that happened. I didn't choose it. It happened to come, and then that then formed the business. So I always the thing that bugs me a little bit about MBAs, no offense, is that they're always like in a room, they're like brainstorming, like, what will I build? And then they're like, let me put a deck together. And then let me go raise money. And then, 99% of startups fail. Right, in my opinion, you should just build a thing first, get users, get people to like love it and pay you for it. And then you can decide if it's a real business and then raise money in a week, but not the other way.
That's actually interesting. You said that you didn't choose, the market chose, but you also chose not to pursue PhD further, and then decided to actually pursue this Lightning AI as a company. Not to mention that the name of the company wasn't even Lightning AI in the first place. It was a slightly worse name that they had. The name was Grid AI.
The lighting, the electricity grid.
Yes, the electricity grid. Actually, there was a story behind it. I could never actually figure out why it was called. So then, of course, the counterfactual reasoning is always very difficult. But then now looking back, what do you think about the decision you made about, let's say, pursuing the startup route as opposed to continuing your PhD? Because there is a major decision, and a lot of the students that I talk to are often hesitant to do anything outside their PhD work during their PhD years, because PhD itself is an extremely demanding thing that they've been working so hard towards. So what made you make that decision?
I mean, they're both very hard things. I really like the PhD. I don't know. I guess I've gone through startups and a bunch of other stuff. So for me, it was like the best time of my life. I wouldn't, I've had great times too. But yeah, you get to do research all day, think about problems. Like, yes, it's stressful because you got to like figure out to publish. But I don't know. I think it's very manageable in my opinion. Again, unpopular opinion. But no, startups, at least in startups, you're gonna die like every day. And so that's very stressful, right? Like you have employees, you have people who invested in the company, they have families, everyone has kids and this and that. Like if you fail, people are out of jobs. So the consequences are a bit different than like you missing a paper deadline, right? Although it feels existential in context, I don't think it's like the end of the world, right? Although if you work with KC, he'll definitely make you feel like it's the end of the world. So 100%. I remember one deadline, he's like right there, and I'm like, it's an hour from now. He's like watching you the whole time. That was good. That was on Facebook. But no, I don't know. Like I felt like, we were at Facebook and trying to train these models was really hard, even with people who are really good. And so if we were having trouble doing it, like how are other people going to be able to do that? And so I felt like it was really important to get out there and help people train on more than one GPU. And even today in our meeting, half the meeting was around how we can get more researchers to use more than one GPU. Well, PyTorch Lightning, right? And all these tooling. And so, and I don't know if it's like correlated, but like the thing that kicked Gen AI off was what? Stability AI, Stable Diffusion. That's kind of like what brought. And that was trained through PyTorch Lightning. So would that have happened at some point? Probably. Would it have happened sooner or later? I don't know. But the fact that they were to train models on thousands of GPUs, they were PhDs, without needing to know how to do any of that, I assume it helped them get there faster, right?
Yeah, that's actually a great point. And then you have the technology that you have built and that you're actually deploying are kind of, let's say, enabling technologies, right? So you're enabling others to do a lot of different things. But when we look at a lot of the AI companies these days, in particular the AI startups, they often struggle not from the fact that the building something is difficult. Well, thanks to your building is very easy now, and they can train these models. But because all these AI technologies call for an amazing amount of the scale, which also, in other words, requires a lot of investment. So we do see that there is, in fact, increasingly fewer number of the AI startups or the AI companies that we actually recognize and can sustain over, let's say, more than a year or two. So what do you think about this trend of the AI companies all being concentrated into a small number of the companies? And then when that happens in an extreme case, right, maybe Lightning is not going to be needed because everyone is going to simply call the OpenAI APIs. What do you think about it?
Well, OpenAI has to run their APIs somewhere, so Lightning is still needed. But yeah, I think ultimately most people should start with calling an API. Probably the vast majority of users in Lightning are building things that are just calling APIs, but they're building the app. An API is one part of a system usually, but that system may still need RAG or something, some sort of fine tuning or something else. And so that's kind of that's what they'll use Lightning for in those cases. I would just say that we used to have back in when I was in grad school, like the ML life cycle was like, observe data, process it, do this, and then train, and then evaluate, and then go back, and that was it. There was no inference or fine tuning, right? But I think the life cycle has changed a lot now, and that's how startups should operate. First, use an API. Don't try to build a model. Don't try to do any of that. Just use an API, build your wrapper, whatever product you want around it, get it to product market fit, get it sold. When I say product market fit, I mean get revenue for it. So they say build things that people want. Anyone heard that? I say build things that people will buy, not want. Like they need to buy. If they buy, they also want it, right? But a buy is a harder, threshold. And so do that. And when you achieve that, then you already have a good business. From there, the evaluation of whether you should train a model or fine tune it or not, it'll be pretty obvious at some point. It'll be a financial decision because you're spending way too much on some API somewhere. And you'll say, hey, I need that now internally because it'll actually make sense to do it myself. And it'll be like simple. You plot it, it'll be like break even right now, do it now. Like it's very simple. And then now the question is, do you pre-train or fine tune? Well, you start with fine tuning, I would say. And then only then, if you have enough data, enough compute, and it makes a big difference, then should you pre-train, right? But that's how I would start. And there's like even maybe a step before that, which is grab an open source model and see what that does without training. But then now you have to manage your inference. So API, manage your inference with an open source model, then decide at some point break even to pre-train or fine tune.
So this actually suggests that the skill sets that one needs in order to break into this kind of startup ecosystem or getting just jobs in this kind of startups and medium-sized companies have actually shifted quite a lot. So for instance, when you started your startup, of course you had to know everything, right? So everything from beginning to the end of how to build these models, train these models, prepare data, as well as even to prepare the infrastructure as well. But what you're saying seems to be that the 90% of the way, until the point at which you can say that your company has a large number of clients who want to buy, right? You actually don't need any one of those. Rather, it seems like just call the APIs, they put some nice, let's say, front end and use a Rail or whatnot on the back end, and that should be it. Is it the case? Or do you still need employees who are actually deeply, let's say, capable and competent in this kind of deep tech stack, even though they're often not going to use them?
Depends on your products. For most products, I don't think so. You can vibe code most of this today, for the record. You can do that on Lightning, by the way, right? So you could grab an API and bytecode it there. But no, you can host the front end, back end, everything in a single place. And then, believe it or not, sales is actually a super important thing. I know you're going to be like, this guy doesn't know what he's talking about. I was in your shoes. But learning to sell is a very, if you think about it, everything you do is sales. Your first attempt at sales is convincing a VC to give you money. You're selling to that VC. Your next sale is convincing someone to join you, and the next one is a customer. So if you can't convince a VC, and you can't convince someone to join you, you're definitely not going to convince a customer. So it's already a bit of a filtering system. And so I think it's intangible skills. Like, you should have product vision, and you should, if you're like, I don't know, a lawyer or something, or you're coming from a PhD in AI, but like you have a very specific domain that you've been in, go build something around that. But don't start with the model. Go build the system around that, the thing that you can sell to customers now. Do that quickly. And that's more like a systems engineering thing that you can buy code also. You don't really need that. and get that to that MVP. So I think the skill set is, can you be as hacky and creative and fast as possible to get you your first deals? That's it. Nothing else matters until that point.
So in that case, let's say you want to, so of course, what you do is that you hire people who apply to the positions that you open up. But also at the same time, eventually what you can also imagine is that you can train people so that they will be able to do what you want them to do at your company as well. So if you were to actually train these people, who can be students, for instance, some of whom are actually here, or you have some of the people who are trying to change their careers and whatnot, what are the kind of aspects, or that you can even name the courses that you would actually tell them to learn, and then what are the things that you would teach them, so that you can actually work with them immediately, and then so as for them to succeed?
Yeah, okay, so maybe go back to undergrad. I'm very old school in this way, I guess. I think your undergrad should be math and computer science and stats. That's it. Do nothing else.
We're happy to hear that Global AI Frontier Lab, but please do continue.
Yeah. No, because you need those fundamentals. Like, company building is largely a math problem as well. I know it doesn't sound like it, but it is. Everything mostly can be modeled by math if you can think in those principles. And then the coding, the CS part actually may be less relevant now. So if you only can do one thing, I would say just do math. And then the other stuff you can learn. And that's undergrad. In grad school then, you obviously want to specialize in whatever your PhD is. But if you want to do a startup, practice building quickly. Like, you go to the gym and you do reps, right? Or like pull-ups, let's say we're doing pull-ups. Well, if you've never done a pull-up, you can't just jump in and do it. It'd be like starting a company and hoping you can do that pull-up. It's not gonna work. So practice a lot before you do that. How do you do that? I mean, I did this. I built dozens of apps before, even launching my previous company. Go on a Friday, go figure something you want to build and try to build it by Sunday night and ship it like live somewhere to the app store, to a website, something. And do that as many times as possible, because you'll learn how to ship quickly. That's the skill set you want, right? Just practice that over and over again. And you'll be very comfortable being able to ship quickly. Also helping you research, by the way, right? I think there's some caveats to research where you need to make sure you're like being thorough in your code and you're testing things to make sure that like your conclusions aren't wrong and so on. It's a bit different. But in the shipping part, you can kind of skip most of that and just like get something live and just get world class at that. Shipping fast.
So this is really kind of interesting, because Jon just let all of us know, by the way, congratulations, about the merger between Lightning AI and the Voltage Park. And then Lightning AI is now one of the largest neo clouds or GPU clouds in US and if not in the world. But it seems like the building a data center seems to be the least build quickly and then iterate. It's like it takes long to build it, and then you cannot really iterate it. If you make one mistake, you probably just wasted about $500 million. So what made you actually go into this route that seems to be the opposite of what you're actually recommending others follow?
So the current state of data center buildings is what software engineering was in 2006 or 7. Mm-hmm. Waterfall, long roadmaps, very slow shipping. And then there's things called startups now that can ship very quickly and they figured it out. Data center build-outs will end up being the same. Mm-hmm. The first instance of that working was Elon Musk doing a data center in 4 months. Mm-hmm. He set a bar. Most data center build-outs take 11 months. He doesn't care. So our goal is to be that. Cool, let's first get to 4 months, and then we need to, from first principles, think about how can you do it faster. There's like physical limitations of space and time that we can't bend, but there's a lot of smart things you can do that a traditional data center build-out person will just wait. They'll be like, hey, I need the government permits. That'll take a year. They'll be like, sounds good. They'll just take it. A startup wouldn't do that. A startup would be like, why do I need a permit? Question until you get to the first principle. Oh, you need a permit because, I don't know, there's no church in this thing. Great, I'll build you a church right now, right?
That actually answers a lot about why the, let's say, building neo clouds or this kind of data centers could be thought of as the building software, let's say, from 2006 that is going to be revolutionized soon. But that actually doesn't answer why Voltage Park actually wanted to merge with Lightning AI. So if the data center is going to be something that we can just build quickly, why would they even need the Lightning AI, which is a software platform company? Can you share that side of the story as well?
Yeah, so first of all, these are aspirational goals. Like, we want to get to building data centers quickly. I'm not saying it's going to happen next year, I think in a few years. So it'll take a while. I'm not sure the other clouds have that aspiration though. I think they're all ran by finance people who grew up in big tech. And so I don't think that they're thinking about this. And so the DNA of the company is not set up to do that. They're just like slow builders by definition. Neo clouds have a retention problem today. So who uses a neo cloud here? Raise your hand. Yeah. Have you gotten, okay, who's bought a GPU on the cloud? No one? Yeah. Yeah, okay, Lambda, sure.
Our students actually have some issue. I need to teach them how to use some
You
cloud.
don't need to log in to Lightning.
Yes.
Just turn it on. No, okay, so what's an analogy? Who's bought a flight online? Yes? Okay, you got some fly? Really? None of you fly. Who's bought a, I don't know, hotel room? Who's made a purchase online? When you made that purchase, you had a lot of choices, right? So what was the difference? Why, like most people when they're buying flights, for most of your life, I guess, you're looking for the cheapest price. At some point, you're like, oh, maybe I want one way. You stop caring, right? And you pay a little bit more. So that's the problem with neoclouds today. It's kind of interchangeable. So I can get a GPU from 5 different places, and they're all not. They don't really have software that differentiates it because I'm just going to get Kubernetes or SSH. Then if that's true, then why do I need to pay any different price? I'm just going to go with the cheapest one. And so that's a problem that they have. So they have a retention problem. The second that, if you're on Voltage Park at a, I don't know, $3 GPU and someone else comes in at $250, you're all going to just go because there's no switching costs. When you are using Lightning software, you actually get a lot of productivity out of it. And it's a bit hard. Like, who uses a Mac here? Right. Who would switch, of those people, who would switch to Windows? Right. Even if the Windows machine was 3x faster, would you do it? Yeah, no, you wouldn't, for the most part. Maybe you would, but most people wouldn't. Because the software is so productive. It's what keeps you there. So they had a retention problem. We had a GPU problem, so we got married.
Well, that's actually a very convincing story. I'm totally sold about it. I'll try out the Voltage Park after this round table. But okay, so that was about the business side of what you have been doing. Now, let's just come back to the university, because at the end of the day, we are in the university building. In this kind of era of, let's say, large-scale AI development that requires some of the startups to even want to buy the whole, let's say, neo cloud and operate them themselves. What is the way for the academia, in particular universities, to train our students on the research that requires this kind of massive scale of the compute? Are we simply just lost on this whole, let's say, battle over the GPUs, or is there some way for us to work together with the industry in order to ensure that our students are trained with the adequate amount of the resources so that they can actually learn how to do the development and research properly? Are we completely doomed, or what do you think?
No, I mean, it's funny because the foundation model companies are mostly researchers. So what do you use in research? A cluster that's running what? Slurm. So most people who start companies, the first thing they do is they buy a cluster and put Slurm on it, right? Because it's kind of like already known. So that's okay, but you're never going to change your patterns with that. Slurm has a lot of inefficiencies, right? There's no way to, for example, inference is really hard on Slurm. Not that you're doing inference as a researcher, but you will in a company, right? Sharing things is a bit hard. Doing multi-GPU can be hard. There's preemptible windows that make things difficult. There's a lot of issues with it. So there's just newer software that works better, right? And so that's kind of like the first problem that we solved was really that problem. And but I think researchers specifically are really opinionated about their workflows and really, 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 really slow to change on these things. And so they're afraid to try new things. And I would say that that's probably the first thing that you have to overcome is this happened in our lab, right? Like, I remember we had a deadline, and the NYU cluster was full, and I think you had some AWS credits or something. And so I had to go to GCP or AWS, I can't remember.
GCP.
Yeah, GCP. Yeah, and then I just spent like 10 grand or something with GCP, right? And on my personal credit card, and then they reimbursed me. But we just needed to hit this paper deadline. And the option was either don't hit the paper deadline or go learn GCP. And I was like, well, I guess I'm learning GCP. I think most researchers, I don't think they would. I think they would be like, nah, it's good. I'll wait for the cluster or something. So you got to get out of your comfort zone. And when you get to industry, you either get out of your comfort zone, they're gonna kick you out of your comfort zone.
Well, I have some of my own students in the audience. That's what we're going to do at our lab from here on, by the way. I think it's going to be very fun. But this actually makes sense in the sense that in academia, we do have this kind of tendency to be more conservative and then try to resist the rapid changes because one of the reasons is that because we have a very long horizon. Some of these things come and go, so we can't really adapt to it every single time. Seems like being able to work with this kind of large-scale compute with the latest software stack is not something that's going to go away, so we probably need to adapt there as well.
Yeah.
So, we're going to soon open up. Yeah,
can I dig into that for a second? So there's and I learned this because I come from startups before research, right? So I'm like, boo, risk forward, like take all the risks, like just break things and figure it out. In research, I had to learn, hey, don't assume every research idea is going to work, right? And that maybe you guys already had that, I didn't. I came in with like, oh, this is gonna work. Oh, this is gonna work. Oh, this is gonna work. And then after a few years, of Kyunghyun being like, stop. then you change your mind to, okay, I'm gonna try the idea, but my goal is that it won't work. And only if you have so much good evidence, otherwise do you treat it as a real result, right? Like who made that change? Who came into academia with that already? Who made that change after like year one? How many years? 3, 4 years? Yeah, it's like a 4th year change, right? I think that's when it happened, 3, 4, something like that for me. Wish I'd done it sooner. Saved me a lot of effort. But you have to have that mentality. It's just a research mentality. And I think in startups you still do for certain things, like making big decisions that spend a lot of money. I still have that. My default is no, unless you prove to me otherwise, right? But when it comes to trying things and risk-taking, your default has to be yes, and it's okay if you fail. And if you've been kind of brainwashed to the PhD program, try to separate those two things out because you do need one brain for the research, but in the other brain in startups, you can't have that because that results into saying, think about your interactions with your friends. I want to start a company. Your default, because you're a researcher, is going to be, I don't think it's going to work, and you'll find 30 reasons why it won't work, right? You can't do that. If you go to Silicon Valley, the difference there between New York and Silicon Valley, if you say, I want to put ants in space, they're like, amazing, how are you going to do it? They don't care. They're just like, great.
Well, that's the reason why I just cannot live in San Francisco and play early myself. I'm going to put you on the spot before we actually open the floor to the audience, is that now that you have become a CEO of a very large company that covers both the infrastructure and software, and then you are a kind of semi-alumni of NYU as well. So what do you think we can do together at the Global AI Frontier Lab at New York University and Lightning AI? Is there something we can do together to have more fun and also expose our students, both from NYU as well as Korea, to this kind of, world of the startup as well as generally a tech world?
Yeah, there's a bunch of ideas, right? But I think probably the simplest, most concrete one is like an incubator of some sort, right? Mm-hmm. Where we can teach skills to people on how to build and ship, and hopefully start a lot of companies. There are a lot of great companies that have come from NYU, for the record. Like I think Jack Dorsey from Twitter was here.
Really? I didn't know.
Yeah.
All right, we need to call Jack for the next step.
Why am I here? All right. Talk to Jack, I think you had, I know him personally, the founder of Runway ML, anyone used Runway ML, also NYU student. He was a video major or something who knew how to code, and he's like, these video people don't know anything about this, so let me take the market, so he did. And then, I don't know many others. I think those are the ones that stand out. But yeah, I think incubation is one of those things, and then this like notion of paying it forward. I spent a lot more time down in San Francisco, and like, there's just a very tight community there. Like if you go to schools out there, Stanford, Berkeley, whatever, it's not that they're like doing anything different. I actually think the research here is better, in my opinion. But
me too.
but there is this like push into Silicon Valley that everyone has all the time, the professors, the students, that everyone's just like willing to try and take risks. And but there's also a lot of knowledge transfer. You can call someone and then they started a company and they sit down with you and teach you these things. And so there needs to be that ecosystem here. And I think it gets created through some sort of incubator where, I'm happy to come and do talks, but other founders can come and do that as well. But these are like, I don't even know where you would learn these things. It's really, don't do an MBA for sure. Like, you're not going to learn it there. No offense. Sorry, an MBA is here, raising hands.
It's good that you haven't invited anyone from Stern, but yes.
Yeah, that's one. I mean, there's obviously a bunch of stuff on how to train models or whatever more efficiently that we use on our products and whatever else. One thing that we're piloting right now at a few universities is connecting their on-prem clusters to the platform so they can run things on there, right? But yeah, I mean, those are things that I want to like let academics have, right? So that they can do whatever they need. Like, you don't need your money, it's fine, right? But I just want people to be more efficient and push research forward, right?
Yeah, this is great. In fact, I'll have to invite you all over to actually next time teach us how to use the Lightning on Heritage Park so that we can actually train, deploy all those different services, and the students can do it immediately on the spot.
And we're happy to put Lightning on your clusters, free of charge, and let you guys use and do the thing.
Oh, that'll be even better. We'll have a follow-up conversation on that one. And well, thanks for answering all these questions. Let's open the floor.
Yeah, let's do that. I will come around with a mic, but quickly before I do that, Kyunghyun Cho, tell us a bit more about the Global AI Frontier Lab itself. That's one thing that we didn't get from this conversation today.
Yes, that's true. I forgot to mention that. I'm supposed to mention it. So the Global AI Frontier Lab was created about 1.5 years ago, jointly by New York University and the Korean government. And in particular, that was spearheaded by the IITP. And then Global AI Frontier Lab was created in order to foster this kind of global collaboration with a particular focus on New York and Korea. And then, in creating so, we decided on 3 strategic directions. One is the fundamental research in AI. 2 is responsible and trustworthy AI. And the third one is AI for healthcare, because we have the NYU LeCun that has extremely, active research going on in this area as well. And then since the beginning, since we went on a full operation about 1 year or so ago, we've been having at any time 20 or so visitors from Korea doing research here in person together with the researchers from NYU. And then we've been actually doing a lot of different activities, including this kind of happy hour, bi-weekly seminar series, and even the full-blown, workshop that was hosted at Seoul. So yeah, this is kind of our way of demonstrating what it means for us to be able to really create a cross-continent collaboration. It's been going so far so good. Hopefully we'll be able to do it even better, and then including more countries as well as the different industry sectors as well.
Fantastic, thank you. All right, so yeah, we'll open up now. Yes.
Thanks, OpenAI.
Yes.
So I was interested in some of your discussion about what it takes to get old dogs to learn new tricks. And I've been somewhat interested in historical linguistics. And they talk about, I think you used the word conservative. So they say that isolated communities are linguistically conservative. So if you want to know what English was like a couple hundred years ago, there's no place in Europe that is as good a place to study it as remote parts of North America, like Appalachia. If you want to know what French was like a couple hundred years ago, the French in Gaspé is more faithful to French a couple hundred years ago than anything in Europe. The converse is where the change happens is typically among younger people, probably teenagers and younger. All right, you guys are all over the hill. And it also is in the inner cities and probably among minorities. And I was wondering if, I think back about when I was getting started in computing, a lot of it was being done I was at MIT, but it wasn't really done by the students. It was done by these hackers who were hanging on, who were kind of, probably high school, all right? And they worked all night, because that's the way we did things, and they were, it's really about language change. And I wonder if you want to get people to change the way they think about computing, maybe going for graduate students is too late.
We have a lot of grad students here, and then I'm pretty sure they are flexible, and then they can still learn new tricks as well. But I actually do agree with you in a sense that we don't want to actually wait on educating students with the new technologies when we believe that those new technologies are going to be really important. And then, in fact, at Global AI Frontier Lab, we actually do host visitors who are, let's say, high school students from Korea, college students from Korea, as well as various other parts of, let's say, Korea and then New York, trying to show them what are actually happening. Now, of course, that's not enough as a kind of education, but perhaps what we can start from is to stimulate them with what can be done with this kind of new technologies that they are not necessarily getting from the formal education. Yes.
Could you break into like the teen pop things, like the K-pop stuff? You know what I'm saying? The cultural leaders as opposed to, engineers.
Absolutely. We'll try. We do have some representatives from the Korean government as well. We'll talk with Dr. Juhi and then trying to figure out if we can actually involve some of those K-pop and then like more cultural kind of, let's say, collaboration into the mix as well. Yes.
Yeah, I would also say, I think the PhDs are fairly flexible. Like, I could argue that the whole point of a PhD is you're learning how to research. And if you're doing AI research, part of that is learning the toolkit as well. So during the PhD is when you would be learning that. I'm not sure. Did anyone train models before your PhD? Raise your hand. All right, some of you. Okay, most of you. Who learned to train models during your PhD? Okay, well, then I stand corrected. Go to undergrads. Yeah.
So you mentioned training data centers, and so I'm curious, where do you think the demand's going to come from? Because it seems like the advantage of size is no longer as big as it used to be. So do you think it's a lot of startups training their own models, or is it just like inference that's going to happen at scale?
Sorry, demand for the GPUs?
Yeah, for the GPUs, yeah.
There's so much demand.
I'm saying, like, from where do you think it's going to come from in the future?
Sure, but let me just factually what's out there right now. Like, how would I describe this? If the GPU demand is this glass here, sorry, if the available GPUs are this, I think the demand is like the Milky Way right now. That's how much it is. Yeah.
And then perhaps from the more of the algorithmic side of the things, I think that what a lot of us are thinking about is this kind of 3 or 4-year-old concept that is that you're going to collect all those data that is available on the internet, and then clean them up, curate them, and then do the pre-training. That is extremely working with extremely regular amount of the data. And then once the pre-training is done very well, we're going to just fine-tune it just a little, prompt it, and then that's going to be it. But I think that that's already old news. What we are actually looking into is that it turned out that the data that has been collected without the purpose tends to have a low utility. So in order to get even more utility out of these AI systems, we actually need to make the AI system discover the data that is needed in order to improve further. And then this connects with all those reinforcement learning as well as the synthetic data generation and all that. And then what that means is that we train data more than once. We deploy it, and then as we serve it, we collect more data, and then based on that one, we're going to produce more data in the background, and then using all those data to continue to train these models. And then what that means is that the demand does not necessarily come from the fact that people are training more models, but now that the training actually never ends. So training and inference and deployment, they are all coming together, and then it actually makes this kind of, let's say, a neo cloud with a very strong software layer on top of that, because the data is also not regular anymore. It's very regular types of the computation that must be done in the continuous manner. So I think it's probably even bigger than the Milky Way, the demand, and then it's going to only grow over time.
Yeah, because the Milky Way is right now, but it is growing demand, and I do think that it converges to, if you just like project it out, like in however long it takes, like it converges to training and inference are probably on exactly the same thing. And it's continuous learning, actually, what probably ends up happening in the long term. But today, right now, if you're asking what happens right now, I describe the funnel. It's a funnel, so where's 99% of the market? APIs. Below that, what do they do next? They grab an open source model and they deploy it. That's called inference. What did they do next? Train. And so it's just funnel. So if you just think about that funnel, like, obviously, the inference is going to be higher. The training will be smaller because that's the smaller part of the funnel, but that's today. Over time, I think it just converges to where it's just continuous learning, and it's just one system that does both training and inference at the same time. Like humans, actually.
Right.
You don't train at night and then inference through the day, right?
Right. Thank you.
Yes, I maybe have 2 questions. One in the business side, now that Voltage is in the deal, and maybe another research one. In terms of just the demand side, and the data center will merge, what's your opinion or information regarding putting hands to them in terms of translate that data centers and that basically equating to energy consumption or the energy equation, this type of deal that's basically happening, which is a restriction, basically in terms of just scalability itself and the ansible question. And secondly, it's in terms of research in the sense that when I follow it, a little bit more research was the burning improvements, hyperparameters, adapters, etc. The 2022, I think that kind of show. Those third things certainly helped training and helped do more efficient things with neural nets. Is that still something that's really interesting to this type of thing now that you have a business layer that maybe might be pulling this optimizations not in place? That's the research question on the business side in terms of energy.
Yeah, so I'm not trained in model study and research, but I still have views, and I actually would love to hear his thoughts. I think, most of the advancements today have been done through just brute force, right? Like, that's not the controversial part, just like scaling compute and so on. At least during my PhD, what we were mostly working on was like more foundational research, like how to extract better signals and, better representations and so on. And so I do, and I think Yann's working on this today. Ultimately, I think that you'll have better functions, better loss functions of some sort that will be more efficient. So you'll get better models through better science, not engineering, but it will take a while to get there. That's where I think research goes. I think we're just brute forcing that stuff today.
Yeah, so at the end of the day, what we are seeing is not the explosion of the models or the energy consumption and so on. That's more of a symptom. But what we are actually experiencing is the exponential expansion of the areas in which these AI systems are actually useful for. And then what that in fact means is that there will be increasingly more pressure to produce increasingly different types of the models. And then we'll have to feel the pressure to deploy them. And then if you have more types of the models and then more heterogeneous models, it becomes overly burdensome to actually deploy them and then use them. So what that actually means is that the adapter, as well as many of the techniques that have been studied in terms of the efficiency, are actually our kind of, let's say, response to condense all those, let's say, ever evolving and then ever increasing number of the different models that we need to deploy. And now, what that means is that we're going to continue to improve the, let's say, underlying infrastructure by increasing the amount of the compute, increasing the amount of the available energy and whatnot. But still at the same time, because the utility is growing so much faster, we'll have to work on a lot of the efficiency-related research in order to condense them down into the form that is manageable under this non-exponentially increasing, let's say, compute infrastructure. So we need to do both. It's actually a orthogonal thing. And it's a great thing at this point is that we can scale up things get better, then we can make the better algorithms, things get better, and then somehow we always end up with something better than before. And this is not a kind of thing that happens that often in the history of humanity, especially when it comes to technology. And then we are somehow seeing this particular moment, this kind of, let's say, we do everything in order to get better along all those different orthogonal directions. It's a great time to be, actually.
Yes, it's amazing. I think Ilya did an interview recently, and he said the age of science is back. That was one of the things he said. I think that's what he meant, in my opinion, because like when back before I started the company, we were doing research. It was the era of science because that's all we were doing, like what are better networks and loss functions and whatever. And then GPT came out, and it turned the world into time to engineer this thing. And now they're like done getting LLMs to be that good. And so now when you hit a wall, now you're back to doing the same thing again. So now you're back to science. So yeah, and then the power question, I think it's a temporary thing. Like I think there's plenty of power in the world. It's just not being used for this today. Yeah.
Hi, great. Thank you for the great talk. I'm completely sold for the idea of like I'm an exchange student from South Korea. I'm an undergraduate student, currently taking Professor Cho's classes in NYU. I have a question about some personal stories because I'm also interested in founding startups. What made you to like first doing a company and then coming back to a school? Because you told us a lot about what made you to move from school to back to the industry, but I was curious about what is available, only in the academia that you thought so which made you pivot in the first place from the start to the PhD.
I think at first a startup is a lot of work, not that the PhD isn't, but it really grinds you down, right? And so when we sold the company, had the option to come work with these guys here. And I was already very interested in research. I just fallen into it. This was 2016, 17, I want to say. So I was already thinking a lot about AI, but not so much in the startup sense, because the startup AI was already solved. I was just thinking about wait, how come I can't do vector representations? Back then it was words and sentences, and then I was personally really, and still am, I guess, with perceptual similarities, right? It was why can't I measure the quality of an image better? How can I understand better representation of the world, right? And so what Yann's doing with the world models, that's a lot of what kind of my PhD was around, starting to do that line of research. And that's just an interesting question. And I just wanted to dig into it and try to see if I could figure it out. I'm not saying I have to solve it, but I enjoyed the science, the process of learning through this stuff, right? It's just, I don't know, it's a pure science enjoyment, I guess. Yeah.
Yep. So if I just got like Yann LeCun had on, his office is right below my office, so I kind of get his kind of ideas, sort of it. So what Yann always tells me as well as all his students is that you don't do research at startups. You don't do research at startups. If you do so, you're probably simply wasting investors' money. If that was the goal, then that's fine. But if your goal is to actually make a company that's going to grow and be successful down the road, then you don't actually do the research. And then that actually makes this kind of academia as well as the PhD programs very, very unique and special, is that we are kind of, mandated to do research. We're supposed to do research. And then, in fact, there's almost no other places in the world, except for a few, exceptions, where you can actually just do research because people ask you to do research. So in this sense, if you want to do research, I'm pretty sure William will eventually again want to do research, and then you have to eventually come back to academia or some similar organization.
Or just move to the mountains, talk to no one, and just read books all day.
Sure, as well, yes.
Right. Ooh, yes, right here.
Hi, thank you guys for the great discussion. So I'd like to come back to some point that KyunHyun brought up earlier about power and energy. I do agree it's inevitable that models get much more power efficient and then much more both in inference and training, etc. But I don't imagine, say, data centers to scale down ever. So my question is, what does Lightning AI and perhaps maybe also the recent merger would mean for the sustainable scaling of model from now on, maybe say until the end of machine learning done by humans?
Well, it just means we're continuously building data centers forever. That is, I think, that's one of our products. We build software quickly. We also are going to get really good at building data centers quickly, and that'll be a core value of our company. That'll be IP of the company, and we'll get world class at that until the world says we no longer need data centers, and then we'll stop building them. I don't see that happening anytime soon. Yeah.
So that said, can I actually suggest that one of our visiting students from Korea who are sitting on the front actually ask one question? That would be great. Hi, don't you have any questions for William? He's our NYU alum and then is a successful startup founder.
Oh, okay.
All right. Yes.
혹시 translating 같은 거?
Sure, I can do that. Next time you can ask a question in Korean.
약간 어색해가지고 너무 좋은 회사인 것 같은데 혹시 이런 AI가 지금 너무 붐이 일었는데 혹시 10년 이후 이렇게 향후에 조금 미래는 어떻게 생각하시는지?
Great question. So,
Absolutely. I know we're still not there yet, technology-wise, unfortunately.
Using Google Translate.
Yeah, exactly. So the question is, So it's actually amazing the kind of company you have built. Like in AI seems to be very successful, and then congratulations on the merger as well. So it's actually going really well. However, will it actually continue to do well over the next 10 years? What do you think is going to happen 10 years later? Where will this company be? And then how the AI scene is going to be like? What do you think?
I mean, if I could predict 10 years out, I'd already be a billionaire. I would just put all my money in NVIDIA, right? I'd be fine. No, I think, look, we are trying to build a new type of cloud. So let's go back, right? So who's used to AWS here? Yeah. So AWS was built for CPU applications, web apps, that kind of stuff. It was not built for AI. And so they are trying to retrofit the cloud by putting GPUs and bringing in tools and so on to make it work for AI. But you can't like turn you can't turn a BlackBerry into an iPhone. Like you can't do that, right? You have to rebuild the iPhone from scratch. And so that's what we've been doing for the last 6 years, is building that new type of cloud. That's for GPU-based applications, right? GPU-based workflows. And so if you think about it, a lot of people today are thinking training or inference or this or that. Those are primitives of a cloud. They just don't seem that way because you're in the creation process right now. You're in the making of this thing called the cloud. It's like you're inside the Milky Way before it's been made, and then only when it's made will you look back and say, oh, that was the Milky Way. And I say that because imagine going back to early 2000s and then seeing this thing called, EC2. And then you're like, wait, this thing is amazing. It's a machine on the cloud. You could reasonably, and there were many startups who thought that was going to be the market. Many startups who thought that could be a whole company in its own. They all went out of business. And then other companies that came in and said, oh, I'm the S3 storage company. And that's all they did. And what was actually happening was these primitives were being put into a little bucket. And then when enough primitives stopped coming out, it got just labeled a cloud. And then that became AWS. So we are in this world where we only have 2 Lego blocks, roughly 3, I would say, maybe 4. You have one Lego block called training, another one called inference, another one called vector DBs, another one called agents, and there are a bunch more of these Legos being built, and they'll be more created over the next few years. But when that whole Lego collection's done, and you put a label on it, it'll be a GPU cloud, and I think we're the first ones who actually are the closest to building that today.
Yeah, thank you. Thank you for the great presentation. I think I could feel at the beginning of the presentation, especially that there's some kind of a tension between, on one side, iterating fast, coding fast, and on the other, shipping a product that's very reliable. I guess people, when they're using your software, they really don't want that something breaks in the middle of training or something like that. So you were mentioning that you could vibe code stuff and ship fast, and I really agree with you for the early development stage. But as the company gets bigger, this tension becomes more pregnant, right? So I was curious if you could explain at Lightning, how do you manage to keep things controlled? How do you double check for potential errors that can occur? And even if you have some kind of maybe example case where something bad happened and how did you solve it? How did you manage it? I think that would be interesting.
So let me actually add one thing there is that I'm going to start it so that the William can wrap it up. I was the first user of the Grid.ai and a lot of the services within. Almost nothing actually worked for about a year or so. Somehow looking back, nowadays it works really well, but looking back, it's almost magical how that actually, that's how it started, and then we got here. So how does this magic happen, William?
It's just normal. It's iteration. It's a lot of failure. It's gradient descent. Literally, that's what it is. Like, imagine, trying to say, hey, I'm going to take my first gradient step and I'm going to land a global min on day one. Like, what are the odds that happens? Like 0. So that's trying to build the perfect startup. This is never going to happen. You have to iterate, and when you make a release to your product and it goes to production, that's taking a gradient step. Then you collect information, meaning, did you hate it? Did it crash? Then so that you take another gradient step. You ship a new feature or whatever, and you do that until you start converging. You can't skip the process, right? We know that. You could never train models that way. That's just the journey. That's what it is. At some point, it becomes obvious when you've made enough hacks and people are using it and it's working, then you kind of like freeze it, don't ship anything. You know, the company, we have something called shipping season and hardening season. So in shipping season, you're just shipping. Hardening season, we're like making it, you know, steady and all that. So you just know, because, you know, you're gonna feel that tension, like meaningfully, not because you're like, you know, engineers are kind of pedantic about code a lot of times. Oh, like the imports are wrong. I'm like, that's not why you feel it. It's not about refactors, it's not about abstractions, it's not about whatever. It's about something is blocking you from shipping to customers now, and that's when you have that tension, right? Then you pause, and you usually have to rewrite the whole thing, just for context. It's not like you can patch it. And there's this tension always in teams, like, oh, we wrote it wrong. Like, software's not supposed to be perfect. I've written a lot of software. It's never perfect. So I think coming into it, just knowing that that's the journey and accepting it and embracing it, like I tell my team, it's like, embrace the suck. That's what it is, right? And just get through it. Yeah, just be disciplined about it. Don't try to do the thing that you're supposed to do at the end in the beginning, because that's called over engineering. And don't do the thing you do in the beginning at the end, because that's just called sloppy engineering. So it's about matching the right tool to the right stage. That's the key that most people miss. Also, like hiring executives or hiring, you know, people in your team, that's also the same thing. It's not like every person is created equal. They're like, would you hire a helicopter pilot to fly a private jet? No, they're specialists. There are specialists at the seed stage. There are specialists at the Series A. There are specialists at the Series B, right? A 20-year Google engineer is going to collapse your startup if you bring them to a seed stage. A seed stage engineer is going to collapse your company if you're a Series Z company. You need that Google person then. It's just different stages, right?
Nice. All right. So I think, well, we'll do two last questions then. I was going to say we'll have one last one. Oh, three. That's it. 1, 2, 3. And so we'll start over here because I can smell the food. I'm salivating. Probably lots of other people are as well. And there's a full bar right behind me behind this wall. So I'm looking forward to digging into that. But we'll go 1, 2, 3.
Thanks for the presentation. Just wondering, right now, as post-merger, what are the biggest challenges you're facing or achieve your goal, pain points, what do you look for in people to help you with those challenges?
Well, the first challenge post-merger is like executing on the actual merger itself, right? What does that literally look like? It usually means that two companies have different operating systems. So like one's using Windows, the other one's using Mac, whatever. You need to pick one. Now like retrain everyone on that operating system. And then from there start learning how to work together and so on. And so there's like a lot of mechanics on how you do that. And so that's kind of what we're going through right now. I think it'll take us another few months to get through. And then from there, it's back to like shipping things jointly. But you know, kind of analogy that I made to the team is like, you can't all magically get on a boat and like row perfectly together if you've never worked together before. So let's learn the mechanics of rowing first. Where to use it, what are the oars, like what's my job in the boat, etc. On dry land, do that there. Practice, right? So we're kind of going through that. And then at some point you start doing it like a little bay, and then you have confidence that we can all do it together. And then from there we can start to execute the thing correctly. Yeah. So that's not a trivial thing to do, but it's all solvable.
Thank you for your great discussions. And as a researcher being on LLM, I do believe there would be kind of like two different research directions. The first one is to scaling up data and, as well as models. And the second one is to how to just make them efficient, how to just efficiently inference or train them in terms of advancing like software as like AI is doing, and also advancing DGP for architectural things. Like I do believe that we already have collected and crawled most of the human-written high-quality data. Currently, we only have a small amount of the data that we only have is kind of low-quality LLM-written data. So which means that I do believe that currently the high-quality data are quite being saturated. So which means that for future years, like the scaling of LM might be just being saturated. So I was just wondering what would be kind of your future plans if like the model and data stops scaling.
Yeah, so if I were in a PhD right now, I don't know if these directions are approved, but I'm a very like, what is it, contrarian person. So I probably wouldn't do what most people are doing, even though it would be annoying because it would take me longer to find something. So I wouldn't try to be scaling models personally. I think like many people working on that. I also wouldn't be trying to scale data because I think many people working on that. But I to his point, I think these are symptoms, and actually working on that is just adding better band-aids than solving the real problem. I would actually be trying to figure out how to train smaller models and have better signals from the data, because then you solve the data problem. You don't solve it, but like I would prefer to go through a data set that has 10,000 samples and get an incredible model that has an amazing representation of the world that's very small. That's what I would be shooting for. I don't know if that's a good direction, but
That's absolutely the right direction. In the sense that the data that we use, there is all those texts as well as video clips and whatnot that are on the internet, were actually collected without the actual purpose. The purpose of why we train these models. And in fact, if you think about the whole, let's say, machine learning, artificial intelligence, is actually a loop. It's not a one-way direction going, one-way arrow going from the data to the model and then model to the products, but it's more like the data actually starts somewhere, and then the starting point is in fact where the model is, and then model on the products end. So there is a loop there. And how we actually create this loop so as to collect the data that is perfectly aligned with the purpose of the collecting data. That's what we need to do. And then that's also where the whole community is moving toward nowadays under this kind of, let's say, relatively vague, let's say, phrase of the AI for science. The key thing about the AI for science is not really science. Everything is science, of course. It doesn't really mean much. But what it actually says is that we want the AI or the AI technologies to be able to perform this scientific, let's say, activities that lead to the scientific discovery. And then in fact, the scientific activities, most of the scientific activities in the natural science is all about how to find the signal out of the noise by, in fact, acquiring the data that's going to help us discover the things that we want to discover. So yes, essentially, in my view, right thing to think about is that can we actually automate the process of the data acquisition so that we're going to break through this, make a breakthrough in this barrier that is set by the existing data. I think that's an interesting direction.
I guess that's the lab in a loop concept.
Oh yes, absolutely. Yes, that's the one concept that I really love. Yes.
Final question.
Final question, Karen.
You had mentioned, Will, at the beginning about you have friends and colleagues in California, and there's just this ecosystem that's really helpful to people trying to start a startup. But you chose New York for your startup. So can you comment a little bit about how you made that choice and why New York?
Yeah, I mean, the first one was a financial startup, so I think you need to be in New York for that. And my co-founder, she had a little network of Silicon Valley people, so we kind of got it through her. But I think if it was on my own, I think it would have been very hard to do for sure. There's an incubator here. I think it might still be around, Techstars, I think it's one. So they help out and they do things like this. And then my second startup, well, it kind of chose me, right? And I was here when it chose me. So that's why I chose New York. But I would still come and build a company here. I think there's an edge because there's a lot of groupthink in Silicon Valley, right? Like in Silicon Valley, everyone's like, what's the Uber for my pets? Or what's like the next vibe coding thing? Like literally every idea is like that. Here, you have like real problems, right? Like you're about to get stabbed in the subway, right? You're not like sitting around Palo Alto drinking lattes, right? So there's like real things here. And so I think it like shows you other things you could do and you meet people from different countries and you have enterprises, and so it's a better hotbed of ideas, I would say, for sure. But if you don't have a supportive ecosystem, then those ideas don't go anywhere.
Yeah, absolutely. So whenever I'm asked this question about why you stay in New York City, there's San Francisco Bay Area and then all the other places, and then because I worked on a biotech base, so there's Boston, Cambridge area as well. The reason is because I think the New York City is great because we get to see the consequences immediately. So every decisions that we make, every decisions we see others make, then we see the consequences, and that actually makes us, I think, they're generally a better people, and then also people who know how to make decisions correctly as well. So New York City is great. Yeah.
Also, I think if you grow up here, you have like thicker skin for startups, which you need, and then you're like more financially literate somehow. You just absorb it by being here, and so you make better budgeting decisions and things like that. Yeah.
That was fantastic. Thank you both so much. Will, Kyunghyun Cho, let's give my round of applause.